Hey everyone, thanks for joining us for another Connecting the Lines podcast. Everything we touch, buy, and use has some form of engineering and product development behind it. Whether it's a simple doorstop or a complex bullet train, the process starts with an idea that then undergoes multiple iterations and testing before it finally makes it to market. Engineers combine inventiveness, knowledge, and problem-solving skills, and of course talent, to bring an idea to life. Today we are going to be taking a look behind the curtain with two highly experienced engineers to discuss the intricacies of product development. So with a combined 37 years of experience, we have Darnell Johnson. What's your current title, Darnell?
Director of New Product Development.
Okay. You started your career as a laboratory technician, lab tech as we call them here.
Yep.
Quickly advanced through various engineering and product development positions. Currently Director of New Product Development, as we mentioned. Bachelor's of Electrical Engineering from University of Akron. What attracted you to electrical engineering?
Just from when I was young, it was always one of those things where I would take apart my Nintendo. I got in trouble for that, by the way, and try to see exactly how it worked. So that was one of the early moments I wanted to go into electrical engineering.
Okay. Multiple patents and member of IEEE.
Correct.
And PLP's best basketball player.
The best.
Is that self-proclaimed, or is that in like an actual voting that takes place?
I've watched these things, and you guys don't fact check because I've heard some things that are not correct.
Okay.
But that is correct, by the way.
Okay. And also the winner of this year's March Madness pool.
Correct.
Right.
Yes.
So
Yes.
I don't remember how I did it, but
I remember you were dead last.
dead last?
The
Okay.
worst. So.
Okay. Well, there's always next year, as we say in Cleveland a lot. Rebecca Alban began your career as an engineering co-op.
Yep.
Quickly rose through the ranks to become product development engineer and then supervisor of PLP's research and testing laboratory, now currently manager of new product development and lab manager.
Correct.
Bachelor of Engineering from the University of Akron, Master's in Engineering from Case Western. So what drew you to engineering as far as pursuing your education in engineering?
Similar to Darnell, I really like taking things apart and putting them back together, just not so much the electrical component. So that's why I chose mechanical engineering. I've always really liked math, science, physics, so it seemed like a natural career path.
Okay. Also multiple patents, and you asked, does your PLP Olympic gold medal count as an achievement? I would say most definitely yes.
Yeah, in the shot put.
Exactly, yes. Arguably more impressive than
I really think
anything
it is.
you've done here.
I told Darnell, though, that a gold medal is far more impressive than an MVP. So
That's debatable, by the way, but the gold medal is impressive. I don't have one, so that's impressive.
All right. So let's get into it. Engineering and product development, what we're talking about today. So both your backgrounds are in both engineering and product development. What's the difference? What would you say the difference between those two
engineering and
disciplines
product
are?
development?
Yeah. Or are there any differences?
I mean, I think new product development is a part of engineering. So that's more focusing on the new products out there, fulfilling specific constraint maps and designs to get new products to the market, where engineering's a wider compass of tech service, quality, and new product development.
Right.
Yeah, I would agree with that. For the most part, engineering in its simplest form is using science and math principles to design and develop or improve a process. So engineering is more of a top level, and then new product development is like a subdivision of that.
Okay. What fundamental engineering principles guide you the most during new product design?
Yeah, I mean, for the most part, it is the core of verification and validation. So when you talk about coming up with something or developing something, you want to make sure it works and it meets the constraints that you were given. So if one of our market managers comes to me with a new product idea, I want to make sure it is effective and it meets their needs for the most part. So verification and validation is you can't miss it. You have to do that in the process.
Right. Those are the core.
Yeah, I think it's a lot to, verifying that the theoretical design is going to actually meet the actual design when manufactured and tested. And it's a lot of checking between theoretical and actual.
Okay. So walk us through a typical new product development process, from idea to launch. I know that's a lot to talk about, but if you could boil it down to just a couple of maybe 2 or 3 steps, how would you describe that?
So we have a stage gate process for our product development process here that starts at more of like an innovation market gate and works its way through the design phases, the implementation, and then basically verification and validation within those. So we'll take the design from conception through engineering specifications, drawing, 3D modeling, finite element analysis to verify the 3D models are going to be fit and function-wise appropriate, through manufacturing, getting the parts in-house, inspecting, testing, and validating, and reporting out those results.
Right. So engineering seems to, I think people think about engineering, I think maybe it's a little bit technical, and but I have to think that there's an element of creativity that goes with it too. So how do you balance, well, first of all, I guess would you say that's correct?
Yeah.
There's an element of creativity, and I know both of you. I think you're creative people.
No.
Shaking her head, no.
I would not be a good person on the innovation team, that's for sure.
Okay, all right. But that doesn't preclude you from being a good engineer.
No. Okay. It's just, I think it's knowing your strengths and weaknesses.
Okay. That's
where
fair.
you need support on those weaknesses.
Right. So I guess the question is, how do you balance creativity with practicality? And there's certainly a ton of practicality when it comes to engineering and product development. So how do you develop those two approaches?
It's a difficult balance, Bill, to be honest with you, because you essentially want something that's functional, but you also want to be on the forefront of different things in the industry. So I can come up with something that's very creative, but if it's not functional or if there's not a need or a market for it, it's pointless. So I think you just have to find that balance in between the two, because we want both at the same time. We want a very functional and a part that works correctly, a part that meets all our needs, a part that's not going to be returned back to us at any point. But we also want to not make something that's already been made before.
So PLP is certainly all our products certainly develop to go into the markets that we serve. These are very technical, industrial markets. We're not engineering toys or shoes or anything like that. So, so when over the course of these projects, these products are designed to not fail. Very dangerous situations if anything in a power grid system fails. So, how do you decide whether to over-engineer something or whether to optimize?
I think, honestly, historically speaking, PLP is always going to over-engineer products. I think in the industry that we're in, you can't risk not over-engineering the product. We want with 100% certainty that our product's not going to fail and a line's going to come down, because that could be very fatal to someone and catastrophic. So we will always over-engineer our products, but also keeping in mind you don't want to, you can over-engineer to the second, third, fourth degree. We want to also keep it so it's able to be sold and marketed within our industries while having that nice balance with a safety factor in there.
Right. I guess you could say the more you over-engineer something, the harder it is to manufacture and the more expensive it is. And,
In a sense, I mean, sometimes the extra material or the extra things that we add to the products may not affect the cost at all, but it just may be that, that thing that we feel I could sleep better at night.
Yeah.
I don't sleep that well, but even sleeping better at night, knowing that, the products that we go out the door are not going to come back to us with issues.
Right. So say something's designed and we're in the testing phase. Talk about failure. How important is failure in this process? Because nobody wants to fail, right? But I know I've heard that that's an important part of the process. Yeah. So why is failure more valuable than success in this process?
I would say so because the way we structured, as Rebecca kind of went through, our phase gate process is front loaded. So there's a lot of work up in the front part of the process because we want to make sure we know all our issues at the very beginning. So we want to fail. We want to fail fast. We follow that approach. So we do a lot of iterative testing to where we may take a product or a prototype, test it, change one small little thing, test it again, change another small little thing, test it again, and then kind of get a feel for what those changes did to get to that final result. So failing is a huge part of the process, and I think I welcome the failure, not to say it like that, but I do welcome the failure because I rather know in a controlled environment in our laboratory than out in the field as the customer gets us in their hands.
Right.
And I think with that too, having failures in our lab opens up the whole project team to understanding what could happen out in the field.
Yeah. Is there ever such thing as a perfect design, a perfect product, perfectly engineered and designed product?
I mean, I think you always have ways to improve. It's part of our foundation with continuous improvement. Nothing ever you want to say is perfect, so it doesn't keep being worked on. I think there's instances where a design we put out there is perfect for its application, meeting all of the constraints that marketing and engineering have set for the product. But I think there's always going to be ways to improve on every product we have.
Right.
Yeah, I mean, in essence, we're engineers, we're problem solvers. It's a quote out there to say if an engineer has solved all the problems, they find another one.
Yep.
So that's just what we do. We're always looking for things to improve on and move forward and expand on the next level and take it to the next step.
Right. That kind of leads me to my next question is, where should engineers draw the line between doing what's been proven, and taking calculated risks?
In this particular industry that we're in, it's for the most part very mature. A lot of the things that we developed have been developed before I was born and Rebecca was born, and probably you too.
Certainly. Since we're talking about 1940s and 50s,
right.
Yes,
I'm just joking,
far before my time.
But definitely, the market, our industry is very mature. So the innovation in this particular industry is very hard to come by. And a lot of people their customers like to have the same thing.
Mm-hmm.
It's on standards. It's written in the book. They point at it and I want this and give it to me now.
Yeah.
So if we present something different, it is difficult for it to get accepted into the industry. But at the same time, we have to be able to be that next, to be ahead of our competitors and not rehash the same thing and rehash the same issues. So I think as we move forward, we want to definitely be on the forefront of that.
Yeah. So it's a tough balance. I mean, really.
It is. Mm-hmm.
Because these products, everyone, as you said, they want what they're used to.
Yeah.
They want the reliable, tried and true design out there. And in our industry, taking calculated risks is on the lower end of what people are willing to do.
Yeah.
But sometimes you just have to jump out there and take them. A lot of things we're doing now, I would have never thought we would have done when we first started here at Preform. So I think, that mentality is changing a little bit as we move forward.
Yeah. Good. You both mentioned that you are patent holders. And What is the significance of that? Is that a point of pride? Seems to me it's something that, if nothing else, it lives forever.
Yes.
And your name is on something that, and so what does that mean to you?
I mean, we have plaques in our office. We get recognized for it's nice. I like the patent program that we have here because it's PLP recognizing, us trying to be more innovative and cutting edge and coming up with creative solutions to problems. So it's just a nice recognition. And I think it's a pride thing.
Yeah.
Yeah, I mean, it's not easy to get a patent, and I think I would have thought it was easy to get a patent, but it takes a lot of work, takes a lot of money,
Years.
and there's investments into it that go into it. So, the ideas that we have, it's something that's not already done before. So if you think about all the things that's been done in the world, and this is something that has not been done before, you start to be a little prideful in that.
Yeah.
Yep.
You have both served as lab supervisor.
Yes.
And what role does the PLP's lab, play in developing products?
I mean, I think a crucial role. Without the lab, you're not developing products. We do all forms of testing, new product development, quality, research and development type projects. So without our laboratory, you're not able to release a single product to the market.
Right.
Our lab's what gives us great confidence in the products we're putting out there with all of our QA testing programs we have. It's a showpiece for when customers come in and we give lab tours and they can, see in person our experienced staff, our equipment, and knowing that if we put a product out there and say it tests well, they're going to have full faith in that product.
Yeah. And they're actually seeing it. So
yes.
that's very important, obviously.
Yeah, I always tell people when they come visit, I toot our own horn. We have one of the most comprehensive labs in our industry. So I can go downstairs as an engineer and just test something. I don't have to send it to a third-party facility and they give me a report back, and I have to interpret the report and say, how did this fail? What happened? And those different things. I get to actually see it, put my hands on it as an engineer, and the timing that I can do that like right then and there. So to have that ability, I think is key for, as we talk about time to market and speed and making sure these products are fit and functional and for our customers.
I think it's a confidence level too. When you're actually able to be down there witnessing the testing, assembling the product, you have full confidence in what the test results are. And the nice thing about our lab too is because we have one of the largest footprints of testing, we're able to help, and we've been crucial on a lot of industry standards committees actually proposing test programs to make sure that they are good programs to be setting, realistic, and that we have the equipment that we can run those test programs.
Right.
It's very rare that we think of a test or think of something that happens in the field and we can't test it downstairs.
Yep.
So, there's definitely some tests we can't do in-house, but for the most part, I can think of an issue that we could have in the field, or a customer may come with us a different custom thing that they're trying to use a product on. We can go downstairs and validate that and make sure it works for their use.
Right. It's certainly a big part of PLP and PLP's brand and culture, really. Yep. So we talked a little bit about creativity before, and I want to maybe look at it from a little bit of a different angle. My background is in creative design, graphic design, and I know a number of people that are product designers and industrial designers. So that's kind of an art school discipline where engineering, not so much. But there's always this form versus function. So is there an aesthetic difference between designing like a consumer product, a toaster or a go-kart or something like that, and more of our wheelhouse is industrial products that really few people see, and visually,
Notice.
is there notice? I mean, kind of designed to not be noticed in some ways. So, aesthetically, is there a consciousness when you're developing products?
I would say so. I mean, I you bring up toaster. Like who thought to make the toaster like a rectangle? Why can't it be a circle? I mean, I don't know, but it looks nice the way it is, I guess. But from our standpoint, the aesthetic portion does come into play a little bit. But for the most part, we're focused more on the, like you said, the industrial side, the fit and the function, and making sure it works more than anything else. But I envy those people who are in industrial design because, I didn't know that was supposed to look like that until somebody showed me it's supposed to look like that. So that is not a huge element of our design process, but it does come into as a factor.
So what innovations or technology are currently changing the way products are developed in our industry? The conversation always gets around to AI, ChatGPT and Midjourney and those things. Obviously, those are innovations, and I don't know if we've gotten there yet. But are there other technologies? And if you want to talk about AI, we can too.
I do think with AI, it's a balance, especially with engineering, because we can use AI to maybe gather or make recommendations, but I think the important part as an engineer should always be verifying that. I don't think in the engineering field, especially the utility industry like we are, we can rely solely on AI to provide the correct answers.
Yeah, I mean, it's all about the inputs and outputs for the most part, what you put in and what you get out and how you interpret that. You might have used ChatGPT to get those questions, Bill, but depending on how you ask that, right? Depending on how you asked, and input it in, it depends on what you get back. So, how do you interpret that? How do you take what the AI gives you and use it for your design and your process? So, I think that's the challenging part of engineering, because do you trust it? Do you not? I think we've dabbled in it a little bit here recently just to get, we can use it for designing and running iterations and computations and coming up with the optimal design, but that's not necessarily what we might end up with at the end of the day. But how does the engineer interpret that, what the program spits out?
Yeah, and that's from the research I've done, that's certainly what I've found. It's a balance, as you said. You can't expect it to do everything, but it certainly can help. I watched a video about Siemens industrial co-pilot for engineering, and it was just an overview. But basically, what it was saying was that it'll cut down, and according to them, reliably cut down, hours of work into 30 seconds or months of work into a day or something like that. I guess it all depends on what you're asking it to do,
right.
But
and how you're utilizing it.
Right.
yeah. But certainly that sounds exciting.
I mean, it does. We talk about AI in terms of design. You can also talk about AI in terms of the products that we provide. So we can develop, smart products that do different things in machine learning. So it's exciting time, thinking about engineering solutions differently. So instead of more static solutions, more dynamic solutions to where it takes that feedback and spit something else out. So I think it's just going to be how we use it here at Preform and how engineers use it as a whole is going to be the touchy part.
Right. So if you could design your dream project, no limitations, total blue sky, what would you design? No budget limitations.
Ooh, I like this.
PLP utility related?
Not even
anything?
necessarily anything.
Man,
You go first.
I need to think on that.
What world problem do you think you can solve? Or not even that. Say it's just something fun.
I don't know.
I would solve getting my trash can from my house to the end of the street. So that would be one of my issues because I hate doing that.
Is this a problem?
Yeah, it's a problem.
Okay.
I don't like it. But you like it? You like taking your trash out?
I mean, I don't mind. My driveway's not that long.
Mine's just long. I don't like it.
So
no, that's just I That's just as a joke, but I would definitely do something you think about the best things and trying to be a great individual in the world, and what can you do with providing water to countries that don't have water, things of that nature. Those are things that I would probably lean more towards than anything.
See, I was going to be selfish and say something around the house, but my pet peeve of mine is children's shoes all around. I want something to automatically pick them all up and put them where they belong.
Right.
Because the kids aren't going to do it themselves.
You need like a Roomba for shoes,
Yes.
right? Just like drives around.
You
That's
know,
nice.
pick up the
It's got a
toys,
front
pick
end.
up the shoes.
Yep.
That would be nice.
Well, work on that.
Yeah.
In your spare time.
In all my spare time.
Or just yell at your kids.
Or just
Either
yell
way.
at them. But,
There's-
functionally, I think of ways to, I would probably lean towards transportation type things. How to create a product to reduce drive times, traffic,
Right.
things like that.
These solutions always seem to be like something that makes life easier for
Yes.
people. Or
Yeah.
those are at least, I don't know, the best products.
Hits a pain point,
Yep.
a daily pain point,
Right.
right?
So in terms of PLP then, what's one product that you wish you had invented? The armor rod, probably, right?
Yeah,
Start
sure.
the whole thing
First
up.
one.
The very first one, sure. Obviously that's our bread and butter for the most part, the helical concept, and we still, tweak that today as we speak. Even from 1947, we're still adding different things and different helical products to the catalog. But I guess I've always been envious of a lot of the telecom closures that we develop. So, the Coyote Dome and, all the intricacies in terms of the different splice trays and configurations and end plates and all the things that go into that. I've been envious of that. So I guess I would choose that.
I was going to say something in telecom also.
Yeah.
I think it's because we don't see that side of it.
Right.
So it's far more intriguing.
Yeah, it seems to just have a different sort of vibe where it's techie and it's, there's millions of different little parts.
Yeah.
And,
The fit of all those parts into one.
yeah,
It's something we don't see as much on the power side.
right.
It's a lot more intricate. I would say they're more creative with their solutions because they are seen more often.
Okay.
So
Yep. Biggest pet peeve during the prototype phase of development?
I think during the prototype phase, I don't want to throw like any department under the bus here. I think sometimes, especially during the prototype phase, a lot of people come in with very high expectations of what's actually realistic. So I would say my biggest pet peeve is unrealistic design, manufacturing. I mean, you can come up with a creative solution to anything, but can it actually be manufactured?
Right.
So that's probably mine is people's unrealistic expectations. Where I think more of a realist, especially at the beginning of projects, just to make sure people aren't getting their hopes up too high.
Yeah. You kind of have to be, right? I mean, that's
Yeah.
part of the job.
Got to bring it a
for
little
sure.
back down, but
Yeah.
yeah, I would say prototype phase is not making actually manufactured designs.
Yep. Darnell, anything?
I would probably say not knowing what you want for the most part. So sometimes the customer doesn't know what they want, but they want it. So how do we get to this point? Yeah. So I think not knowing what you want and then kind of going back and forth and, add this here, add this there. And we don't like that. Yeah, we kind of like that. I think that's the biggest pet peeve for me.
Okay.
And adding on to that, it's not even so much like you propose something because they don't know what they want, and then they just say, no, that's not what I want, with no clear direction
Correct.
on why it's a no.
Yep.
Right. What's the most used tool or your favorite tool in your process, in your day-to-day job?
Favorite or most used? I feel like those would be different.
Do both, yes. Oh, you're overachiever.
Why not
Do
do
both.
Yeah, my favorite would probably be Creo.
Hmm.
I don't get to do it as much anymore, but it's always interesting to get in there and 3D model and see all the features and functions and then do some finite element analysis off of that.
So is Creo basically the most used engineering software?
For 3D modeling?
Yeah.
Yeah, here in Cleveland.
Okay.
Mm-hmm.
Yeah, I mean, unfortunately, we don't I miss it.
We don't
get
do
a
it very
chance
much
to
anymore.
get to do that and use that as much anymore.
Right.
Not designing as much as we used to. But yeah, I would say that's the most used as an engineer on a day-to-day basis. You know, they're always in there, the CAD software modeling something or doing some type of finite element analysis on that particular component. So
what about something that's physical, like I don't know, torque wrench or slide rule?
I mean, most used probably physical. It's going to be calipers for measuring and inspections. I'm sure most engineers are probably going to be very similar on that.
Okay.
But I mean, our engineering staff is very hands-on in the laboratory, so it's not uncommon that we're down there using tools that we use to apply products, standard tools.
Yep.
You mentioned slide rule, and I don't know.
Yeah, I don't think anyone's using slide rules anymore.
That's another thing probably before my time.
I get looked at. I have dial calipers, and people look at me like I'm old.
I get an abacus out of it.
What advice would you give to young engineers who want to get involved in product development? Is it become an accountant or run?
You can go first.
I guess I always I guess when I'm looking for someone, when we're hiring a new engineer, I guess I'm always looking for someone who is, that cliche term of a sponge. So someone who's willing to learn and actually applying those principles that he learned. Because you can have several kids in the same class, they learn the same thing, they learn the same principles, same equations, but how do you apply it? How do you take that next step? And you don't have to do that, but how do you apply it to some of your everyday principles and different things? Maybe it's something that you're doing around your house or a home project. How does that engineer take that next step and absorb all the information and different information and brings that in and applies it? So I would say the advice I would give to a young engineer is take that initiative and using those principles in different applications.
Okay.
I would probably tell them that, the stereotypical engineer is maybe a little socially awkward, not so great at communication, but you can design a phenomenal product, but if you can't communicate that with your project team, it doesn't leave you anywhere. So I definitely think they need to focus on their design capabilities, obviously, as a new product development engineer. It's your main focus, but really don't forget the communication portion of that.
Right.
Especially here at PLP, we're daily in multiple meetings with cross-functional teams. You have to be able to work in a team and communicate within that team.
Right. Yep, I would 100% agree. Even in marketing, maybe even more so in marketing, that communication skills extremely important. So, yeah, that's a good answer for sure.
I think people think when they go into engineering, they don't need that portion. Same with technical writing. They think they don't need to have those types of skills, but you really need those soft skills to be an efficient engineer.
Right.
That's true. We've encountered a few who have not had those, so it makes it a lot difficult to get your point across to those other individuals who are part of your team. And I think that's a thing. It's not a silo thing when we talk about development. It's a marketing, manufacturing, purchasing. These are a lot of people involved when it comes from getting a product from conceptual to actual get something in your hand. So having that engineer, as Rebecca mentioned, with great communication skills makes that process a lot easier. But if they don't, then it's it's more difficult.
It can be an uphill battle.
But they're a genius engineer, though.
It's finding the balance, right?
Yeah, right.
You have to have that balance.
Teams messages. There you go.
Yes. That's why Darnell likes the Teams messages.
I don't like talking.
You don't have to talk to anybody face to face.
Just send them messages.
Is there a fun aspect to engineering? I know both of you, and I've had fun with both of you. What makes engineering fun?
I mean, for me, I really like, when you finally you've spent months developing a product, manufacturing it, actually seeing it test in the lab, and when it passes, it's fun. I mean, you get to check off that box that you made a successful product.
Yep.
I also really like to do that last percentage and close out the reports. I like crossing things off my to-do list. But yeah, I think it's fun, you know, watching the product that you've spent hours and days and weeks developing, actually seeing it apply and test in the lab.
Right, exactly.
Yeah, I mean, for me, I think the fun part, and especially here at Preform, we like to give our engineers like a lot of diverse projects. So they could be working on something to where they're developing something to hold 40 or 50,000 pounds of tension on a conductor, to developing a wildlife protective product. For instance, squirrel protector.
deterrents.
So you know, you're designing a Ninja Warrior course for squirrels to hurl them off the power line. So
Right.
you know, the diversity of the projects are, I think, a great thing that we offer here at Preform, because I'm not pigeonholed to one thing. You know, I can work on robotics, to wildlife, to telecom, to different things, and I think that makes it fun every day and exciting to come to work, because it's a different challenge every day, and it's not the same old mundane thing.
Yeah.
That's the very fun aspect of what we do here at Preform.
Yep. I would definitely agree with that. It's always something different every day.
And one of these days, I'm going to ask to fly the drone. I think that'll be fun too.
We have backups. It's okay.
We have backups. We need those.
Okay. Thanks so much for your time. I have one last question, and it is probably the most important question.
Okay.
Tacos or pizza?
Tacos, 110%.
She didn't even think about it.
Tacos, always. We get Mexican every Friday night. I'm pretty sure mine and my husband's relationship was the foundation is tacos. Tacos and margaritas.
Okay.
Hers is sentimental. Tacos. I would say pizza, honestly. Pizza.
Really?
I've always grown up on pizza. I was introduced to pizza first, more than tacos. I think tacos in my household was like a, you know, we get it once in a while, but we got pizza every Friday night. The Pizza Hut book, you got to read a book.
Oh, yeah. You get
and
an A, you get a pizza or something.
So I was like, yeah, let's do that. I want some pizza. I'm going to read this book real quick. So it is pizza for me, for sure.
See, it's sentimental for you also.
Yeah, I guess, yeah.
All right. This was great. Thanks so much for agreeing to do this, and thank you for your time.
Did we agree?
Did we ever? Yeah.
No, thank you.
Thank you.
It was fun.
Thanks a lot.
Thank you.
Yep.